All right. Caitlin, give me one word. Tell me where it goes. Okay. Increased by. In addition, I agree. All right. Aiden? Very good. Is goes in the equals column. And adjust yours as we go over these. If you've got one you didn't know where to put it, put that in the spot, or if you got it in the wrong spot, fix it. All right, Blakeland?
Decreased by.
All right. Decreased by, where's that one go?
Subtraction.
Perfect. All right, we got that one. All right, Lanaya? Good. Minus right there. Subtraction. Riley's not here. Evan?
More than. Addition.
All right. More than. Addition. Very good. It's okay. Rosalind? Very good. And where is triple? Oh, right there it is. And specifically, if you see triple, what are you multiplying by? 3. So I'm going to put times 3 there beside of it. So it's a specific type of multiplication. Riley. Aiden? No. Product of is going to be multiplication. All right, Haley? Very good. And specifically, what are we multiplying by there, Haley? 2. That's 2. All right. Isabella? Okay. Multiplied by, or let's see. Do I have multiply on there, or is it multiplied by? Multiplied by. Okay. All right, we got that one. All right, Lanaya? Very good. Total of. All right, Blakeland?
Plus.
Good. Where's that one go?
Addition.
Very good. Where's it at, though? Why am I not seeing it? There it is. Plus. All right. Giancarlo? Half will be division. Where's that at? There we go. Specifically, what are you dividing by if you are doing half? 2. All right, Anna Grace? Good. Per is division. All right, Rosalind? Good. Together is addition. All right, Ian?
Fewer than is subtraction.
Good. Fewer than subtraction. All All right, Haley. Good. Times will be multiplication. All right, Kama. Back. Good. Thank you for announcing that to the class. Make sure you got your water bottle.
You got this.
Goodness. Oh, some. All right. Let's see. Anna Grace. Very good. Difference is subtraction. Okay. Anya. Sum is addition. Very good. That's good. No. There may be some, like you also said that for product of. So these 4 words, product, sum, quotient, and difference here, which actually I should have quotient marked off. I forgot it. There's a possibility that a teacher has taught you that equals goes with that somewhere because they're kind of, those are all like related. They're like nouns that we use, so that might be where that's coming from. But specifically, it is what it is equal to when you add 2 numbers. So we're going to put it in the addition category. All right, let's see. All right, Caitlin. Ratio of, for which one? Perfect. Ratio of is for division. Because ratios, they can be written something like this, 2 to 3, but they can also be fractions, which means it's your dividing. All right, Kaylee? Yes. Usually. Depending on, it's usually going to be subtraction. For example, like to give you an example of that, Anya has 10 apples. Giancarlo steals 4 and eats them. How many remain? So that would be an example there. For that, there is a chance I might could see division possibly. I don't know. That'd be a stretch. I would put it with subtraction. Did I mark that one off though? Yeah. Okay. Isabella. Combined addition. Good. All right, Lexi. Yields is equals. Very good. All right, Evan. Yeah, we're getting down to where it's. Okay, good. Added 2 is addition. All right, Giancarlo. Very good. Double. is multiplication. Specifically, what are we multiplying by there? 2. All right. Sven is not here. Aiden? Will be is equals. Very good. Not usually in real life sort of problems. If it's one that teachers have just made up, which we'll have some of those, then you might see it. But usually in real life sort of problems, it's some form of the verb is, right? Is, are, was, will be, some sort of. That's what we see for equals mostly. All right, Giancarlo.
Out
No, I don't think I put it for equals. Out of, he said equals. Let me give you an example of how that would be used. For out of 5 people love math. So it's division, because that would be like a ratio that it's reporting. So I would put it for division. We're getting down to the difficult ones now. All right, Anna Grace. Sold for is going to be equals. All right, Rosalind. I know it's very small. Less is subtraction. Good. All right. All right, Kaylee. Was, were, less than, of, gives, percent. Less than is subtraction. Good. Here, I'm on. The ones we're left with, I'm going to highlight them green so you guys can see which ones are left. They're hard to find now. All right. Lexi. Percent is division. Very good. Specifically, what is it divided by? It is 100. Because the word percent means per 100. Cent, if you think of that prefix cent, where else do we see that? Century, cent, the coin. There are 100 cents in a dollar. There are 100 years in a century. So cent right there refers to 100. And we know about percent, it's per 100. If 95% of Miss Hyatt's students love math and think it's their favorite subject, that would be 95 out of 100, right? All right, Anya? It is not. This one's a tricky one. This one always messes my mind whenever I was. It's multiplication. If you see of without, like out of a certain amount, then you will divide. But of just by itself is typically used with percents, and it might be like 25% of people, of students, play sports. So you would take 25% and multiply it by the number of students that you have. Or another time you might see it might not be a percent, but it might be like half of people So you do half times that number of people, or 3/4 of the people all did this. So that's where you would see that. But that one always kind of didn't totally make sense to me. I remember in school whenever I was learning it. But it does mean to multiply. All right, Ian, we're down to 3. Was, were, gives.
Was subtraction?
No.
Equals?
It's equals. It is just the past tense form of is, right? So it would just be like the past tense form of something. There are possibly some scenarios where you could use the word was so that subtraction could be implied, but it would need more words with it to for sure be subtraction. All right. Let's see who gets these last ones. Evan?
Gives the subtraction.
Well, I mean, I can see how you would say that. Like, Evan has 4 apples, he gives 3 to Rosalind. How many apples does Evan have? That would be subtraction. But what about if Evan has 3 apples, Rosalind gives him 3 apples?
Well, then it would be 5.
That'd be addition, right? So I will give you that it could be either here or here, or I think it can go somewhere else. I think it goes for equals. I was thinking of equals whenever I did this problem, but there's an argument that it could go for addition or subtraction, I would say. If it went with division, you would need it to be like gives to each. But then it could be like if Aiden brings us all cookies and he gives, if Aiden gives each person a certain number, it could be division for that. Also multiplication. I mean, it could be like it could be division, or depending on how you ask. Like if Aiden gives each person 2 cookies. That could be asked as a multiplication problem, like how many cookies did he have? Or it could be given as a division problem, like he had 40 cookies, he gives everybody 2. So we maybe could put it there too.
It's everywhere.
All right, so the last one is were. Lakeland, what do you think? What? Were. Like, there were something. It would be something like the sum of a number and 3 gives you 10. Right. So that's the kind of phrase I was thinking of. Were is just another form of the verb is, right? So were is an equal sign also. Is, was, were, will be. It's just all different tenses of that same verb, right? So if the problem is in past tense, it's possible that they would put were. For example, if you were, I don't know why you would do this problem, but last year, last year, Ian had 5 cats and John Carlo had 10. How many cats were there all together? So instead of is, instead of being present tense, it would just be past tense there. All right, so these are not all the words we need to know, but they should help us a little bit on deciding what to do for these problems. So So that's our variable. That's what we don't know. So when you're writing an equation for this, read through the situation, okay? The sum of, all right, so what's the word sum tell me to do? Add. So whatever comes after this is going to be the two things I got to add together, right? So I've got his age and Mrs. Hyatt's age. Do I know his age? What is it? 30. So I don't have to use a variable for that. I know that it's 30. Plus Mrs. Hyatt's age. Do I know it? No. That's what I'm using my X for. Okay? So the sum of his age, 30, and Mrs. Hyatt's age, X, so 30 plus X, is, what's that tell us to put? Equals. Is going to be our equal sign. So here's where our equal sign goes. Then I've got 6 less than. What does less than tell me to do? Subtract. But when I see less than, okay, is it 6 minus? It is not. It means I'm subtracting 6 from the end. So I'm going to leave myself a space right here and put a minus 6 over here. Okay, so it means I'm subtracting 6 from the next part, which is twice Mrs. Hyatt's age. Mrs. Hyatt's age is X, right? Twice X would be 2X. Okay, now we just solve. Alright, so, Lexi, what would I do to solve this one? I'd subtract that X first. 30 equals X minus 6. Then I would add the 6. 36. So I'm 36. Not 60 either.
I was close. My first guess is actually like 32.
Okay.
I guess 34.
Yeah. So your best bet when guessing somebody's age is to actually guess it and then take it, I'd say at least 5% off. Unless you're guessing a little kid's age, then always guess high. Cause if you're guessing that a kid, if you're guessing a kid is 5 and they're really 8, they're going to be insulted. So.
I always like just doing it like, it's a joke, you're 200.
Yeah.
Because you can never be wrong.
I had him the very first year that I taught. So the very first year I taught here, I was 23. Well, yeah, I was 23. Or maybe 24 if it was second semester. But yeah, and he would have been like 15 or 16, yeah. So, 36. Getting old fast. I am, huh? I graduated from college in 2008. I know, that's the year you were born. Yeah, I'm literally old enough to be your mother. I would have had to. Yeah, I wouldn't have even had to have you that young at this point. Yeah, I would not have even had to have you guys that. If you guys are 14, I would have been 22. I wouldn't even been that. I mean, it's a little young, but it's not that young. It's not like having a kid in high school. So. Yeah. Yeah. So, getting old fast. I'm going to tell you, I thought when I saw your name there and your dad's name was Eddie, I thought that it was possible. I was trying to count it up. It's like, no, I think he would have had to have her whenever he was in my class, if that was the case. I was, yeah, yeah. How many years have I got? What grade is she in? I may not get her till if she's in AIG, I might not get her till she's a junior or senior, so maybe I got a little while. I know, like, I taught Miss Martin, and her little girl is in Henry's class, so I know they're coming up with that crowd, but that's kindergarten. I got a little while till I get there, but when I first saw your name and that your dad's name was Eddie Bobbitt, I was like, no, this can't be happening already. I'm not teaching a kid of a kid already. Yeah. So, it did not specify a junior or senior or anything there, so then I was like, oh no. Yeah, and you look a lot like him, too. You guys look a lot alike. So that first day I was like, no, it really is true, but it wasn't. I'm not that old yet. Yes, but it's coming up fast. I know that I did have a student who had a kid the same year that I had Hunter. She was still in high school whenever she had the kid. But I don't think they live in Elk anymore. But if they did, when Hunter gets up here, which is 3 years away, there would be the possibility of teaching a kid who have had their parents. So it's coming up fast. Yeah. Yeah. Yeah, see, that's coming up fast for me. Oh, gosh. Yeah. All right. All right. Okay, are you skipping ahead and doing number 2? No. Did you write the equation? All right, Haley, let's see what you got. All right, you got parts of it right.
I did 4 minus.
All right, so. All right, so first of all, let's ask ourselves, what is the, unknown thing here? What do we not know? The number, right? So when we see a number, that's where we're using our x. So when we see this number right here again, that's going to be our x. So 4 less than, that's the minus 4 part, twice a number. Did you guys do anything with twice? Okay, that's multiplication specifically by 2. So I should have a 2 with my x. It's twice the number. Now, let's talk about this. Is it right to do 4 minus 2x? It is not. How do you know? You could do it that way. That would be correct. But in general, what I usually tell students to do for this part, when I see 4 less than, when you see that than right there, you're not doing 4 minus. You've got to do minus 4. And then it's 4 less than twice a number, so the 2x goes over here. It is correct, Aiden, to do negative 4 plus 2x. That's also okay to write it that way, if you would prefer. But most students usually write it this way right here. So when you see the less than, instead of doing 4 minus, you got to do minus 4 from whatever's coming after it. Okay? And then what does is tell us to do? Equals. Actually, it is equal to. That's even more obvious that that's equal, right? Okay? And then I see sum. What's sum tell me to do? Add. And I got to add the 2 numbers the 2 things that come after it, right? So it's the sum of the number. The number is x and 7. So I'm adding x plus 7. I agree. These are confusing. And especially if you just like try to read it and then understand what's happening right now. Walk yourself through each word. What does each word tell me to do? Okay? Now, these equations shouldn't be that bad once we actually get them set up. So, Camo, what would I do to solve this equation? Very good. I'll subtract that x. And that will just give me a single x minus 4 equals 7. And then, Camo, what's the last step here? Add that 4. So what do I get for my answer? 11. Now, both of the first one maybe is sort of like a brain teaser sort of problem. The second one is definitely just like a teacher made this up, contrived it to make your brain work sort of thing. Neither one of these are too real world. So let's look at one that's much more realistic, okay? All right. Now, this is a reality if you go get a cell phone, right? So if you go get a cell phone, yeah, for most plans, you have the option of either just like outright buying the phone and then your bill will be lower each month, or they let you roll the cost of the phone into your bill each month, right? So, either way, you end up paying for the phone, but depending on how much they're charging you, it could be cheaper one way or the other, depending on what kind of like promos and stuff they have. So, let's say that you are trying to compare two different companies. The first company does not roll over your cost of the phone. You have to pay $600 for the phone, plus $85 per month for the unlimited plan. Okay? Cell phone company B, they charge $125 per month for their unlimited plan, but the phone is included. Let's assume this is the same phone, right? Because otherwise, then that might make a difference in your decision. If the included phone is like a really bad phone, you might not even really want it or something. It's not what you're wanting. So we want to know at how many months would the two plans cost the same? Because if you were only going to have your cell phone plan for 1 month, right? For company A, you would have to pay $600 for the phone and then $85 for your 1 month. So the first month is going to cost you $685, right? The company B would only charge you $125. Now, I get there's going to be limitations on, like company B is going to make you sign a contract where you got to pay it for so long, or you got to pay off the phone sort of thing, probably. But if we had this set up for 1 month, company B is going to be a lot cheaper. You might consider this if you don't have enough money to pay for the phone at the beginning, right? Like if you don't have $600 to drop on a phone. Because with cell phone company A, they're going to charge you $685 that first month. Whereas B is only going to charge you $125. But, there's a $40 difference between how much these plans cost each month. So what we want to know is when would it be equal here? So let's write, first, for all of these, we need to know what the variable is. What do we not know? What are we trying to figure out? Well, we know cost. We know the cost for the phone. We know the cost per month. So, cost we know. All right. At how many months? How long, right? So, X, here, the unknown, is number of months. You can usually figure out what your variable is supposed to be based on the question that's asked at the end, right? So, in this case, it's asking you how many months. So you don't know months, so that must be your variable. All right? So for company A, we are going to have to pay $600 for our phone, right off the bat, plus $85 per month, right? So $85 for each month. So if it's $85 per month, it's $85 for each month. So 85 times X. We might should have put per in the multiplied column also, now that I think about it, because it does mean to divide most of the time, like if you are going, 100 miles per hour, it's 100 miles for every hour. But in cases like this, if like you have a charge for every month, a lot of times it's going to mean to multiply. So, okay, this is cell phone company A, right? What would the equation for company B look like? 125x. There's no number added to that because they just charge you 125 times however many months you use their service, right? So, I've set up the equation. Now I need to solve it. So, let's see. Rosalind, what would I do to solve this equation? 600 plus 85x equals 125x. Good. We'll subtract that 85x. So we'll get 600 equals 40x. And then what will we do after that? We'll divide by 40. And let's see, that's going to be 60 divided by 4. It's 15. Something like this I might put on calculator active or inactive. Whenever we get to some of these, I might let you use the calculator because sometimes nothing we've done so far would be too bad without a calculator, but we may get into some later that do. Okay, so 15 months, the plans cost the same. So after 15 months, company A is going to actually be cheaper for the long run there. I mean, because you're only paying that $85 per month there. Yes, usually it's at 2 years though. So if this were the case, you would still at 15 months the price would be the same. So you would still have, like another 9 months you'd have to pay on your phone for the other company until they bumped it down to a lower price because you weren't paying for the phone anymore. So it's typically for most plans at 2 years that happens. So now we don't have a whole lot of information on these particular cell phone plans. So we would maybe need to ask those questions if we were there switching over. Okay. Yeah, you need to ask questions, though. That's good. So if you want to keep the phone for 2 years, A would be cheaper, right? Assuming that B is going to charge you that price for the whole time. As long as you got $600 to pay for the phone at the beginning. If you don't have $600 saved up, you are not going to be able to do company A, right? Because they are making you buy the phone outright at the beginning. All right. I'm going to skip this one for right now because I want us to get to all of them, and it's similar to a couple that we've already done. All right, before a fundraiser, a club had $68 in its account. They made 50 cents for each candy bar that they sold. After the fundraiser, they had $102.50 in their account. how many candy bars did they sell. I recognize this one is one you probably could do without writing an equation. Or some of you may be able to. But for all of these, like on your homework tonight, all of these we are, oh gosh, it's 307. That you're not going to do every single one of them. So I want you to write an equation for every single one that we're going to do anyway. So for this, they had $68 to begin with. When they sold the candy bars, that added to their account, right? So it was 50 cents for each candy bar. Do we know how many candy bars they sold? No. That's where our X comes in. That's our variable. And then after the fundraiser, 102.5. So that's going to be equal to 102.50. All right. So, Evan, how do we solve that?
First off, we are going to subtract the 68 from 68.
Good. Which means I must also do that over here. And so, okay, 34, right? 34. All right, and then I've got to divide by that 50 cents. All right, dividing by 1/2. What's it the same as? Because this, I could call it dividing by 1/2, right? What do we do when we divide fractions? Easy as pie. Flip the second and multiply. Dividing by 1/2 is like multiplying by 2. So we're really doing 3450 times 2. So 69 candy bars. Okay. Alright. Just do the first 3 problems. Sure, go ahead. Alright.
Y'all are dismissed from this class.
You gotta get the picture. Alright, 1 through 3 are the only ones you have to do. Just the first 3 problems. I apologize for being slow today. Just the first 3. Alright, did everybody get one? Sorry. Jeremy, you can't remember that phone, can you?